Welcome back. We are here with Jeff Phillips. He is Senior Product Manager for LabVIEW at National Instruments. Jeff, we've been talking about your research around 5G, and I wanted to ask you specifically about small cells. We've heard for several years now that small cells were just about to take off, and it really hasn't happened as many people predicted yet. What are you seeing in your research that might actually change the trajectory for small cells?
Of course, yes. As you mentioned, small cells have been the front runner in 5G research for the last few years. And I think as you look at the emergence of massive MIMO and millimeter wave as complementary technologies, I really think that the development of those, the theories behind those will help small cell get to the point where a lot of the pundits were expecting it to be, frankly, by this point already. The higher frequencies that we're seeing at a millimeter wave will help with the application of densification within the small cell research area. And I think that combining the theories behind millimeter wave and packing together a higher frequency and at some of the more exotic frequencies like 73 gigahertz will really enable the application of small cell in a higher frequency range where you can really start to take advantage of the theoretical advantages behind small cell densification.
Okay, great. And you did mention 73 gigahertz and the exotic frequencies. You know, I've heard 30, I've heard 60, but you've probably got a good line on it. What are some of the frequencies that we're going to see?
Yeah, so the Nokia Network's working example is the 73 gigahertz link, and that's the fastest working link that we've seen. We've seen some in frequencies like 28 gigahertz and 38 gigahertz, and some at 60. Those are the four kind of primary gigahertz ranges that I've seen functionally. 73 is by far the largest band that we've seen a functional link working in.
Now, how did these get identified? Just trial and error, try each one? Or?
Yeah, I mean, honestly, above the 6 gigahertz range, a lot of that frequency band is largely unclaimed, which is where a lot of the excitement behind millimeter wave comes from, is because there's just so much more bandwidth available that a lot of the research initially going into 5G were, how do we get more bandwidth through just the 6 gigahertz, the under 6 gigahertz frequency ranges? And when you look at the Shannon theory, you know, we're already kind of at the edges of signal to noise ratio with a lot of the advanced signal processing techniques. And when you've maxed out signal to noise ratio, your only other option is to increase your bandwidth. And so going above 6 gigahertz and even into the 28s and the 38s give you just such a wider range of frequency spectrums. And now some of the more advanced signal processing techniques and using high gain and phased arrays give you the advantage to take care of some of the loss, the high loss that you typically would have seen in those frequency spectrums.
Well, it is exciting.
It's
Jeff
very
Phillips,
exciting.
Senior Product Manager for LabVIEW at National Instruments. Thanks again for coming into the studio today.
Of course, thank you.